So now that we've talked about the program behavior and you see how the data is structured that it works on, let's go ahead and take a look at the source code. Here is the entry point into the program. It's very simple. All it really does is it just goes ahead and has a main entry point into the program, and that main entry point will parse the command line arguments and stash these away in something called an options singleton, which is a convenient way of getting access to things like what's the max depth and other information you might need. And then it creates an object that will count the images, and the constructor of this image counter object is where all the fun stuff begins. So let's go ahead and take a look at that. So here is the program that will count the number of images in this recursively defined folder structure, and it'll use the Java sequential streams framework as well as this teeing collector. And as I mentioned before, the root folder here, all the folders can either reside in my local file system or in a website somewhere. And it's kind of cool because the program abstracts away from all that stuff by using a package called JSoup, which is a XML, HTML parsing package. So one thing we're going to have here is a field called mUniqueIDs, and this is going to cache the URIs that we're visiting so that we don't visit the same page more than once. No sense in visiting a folder or a page that we've already seen. And it does that by using a really interesting feature of concurrent hash map called KeySetView. And a KeySetView is basically a concurrent hash set where you can have a mapping of keys that, in this case, are going to keep track of the URIs that were processed. So that's what the KeySetView is, and you'll see how that's used here in a second. So here's the constructor. That's where everything starts. First thing we do is we grab the root URI, which comes out of the options singleton. You can set that to whatever you want it to be. In my case, I'm doing something locally off of my file system here, and that's what it sets to be. It sets to the root URI in my file system, which, as we saw before, was over here in the resources portion of my program. And then we're going to call a helper method called countImages, which takes the initial root URI and an initial depth count of 1. And then it's going to traverse recursively, get a total number of images, which we will then go ahead and print out here. All right, so let's take a look at countImages. So countImages does a little bit of sanity checking first. First thing it does, it checks to see whether the depth that was passed to it as a parameter exceeds the max depth that was stored as an option. And if so, we print it out, and then we return 0. We're not counting something if it goes beyond the designated depth. The next thing we do is kind of fun. I think there may be a way to simplify this. I just haven't updated it yet. We then atomically check to see if we've already visited the URL or the URI in question. And if we have not visited it, we add it atomically to this mUniqueURIs field. If we have visited it, then we are just going to bail out because we're not going to double count links of what we've already seen. And this uses a very cool technique called atomic check then act, which goes ahead and checks to see if the URI already is in the map, and if not, it gives it a default value. If it is, and goes ahead and adds the URI to the map, and otherwise we'll go ahead and just bail out, return non-null if we've already done it before. So that's a little clever technique. We'll talk more about that if you take my other course on concurrent Java object-oriented programming, because it's a cool synchronization technique. Assuming we get through those sanity checks, now we're going to go ahead and really start the main work of this whole program, which is going to count the images recursively, and it'll count the number of images on the page we're looking at right now, and it will also recurse through any links on that page and count those images that are reachable there as well. And that will then go ahead and give us the total count, and we return that count as the result. So let's take a look at countImages impl, and this is where we do the teeing collector stuff. This is really funny and cool. So the first thing we do, somewhat along the lines of your assignment 1A and 1B, we are going to get the start page, and then we're going to turn that into a stream. So we'll have a one-element stream consisting of the contents of the page. And let's go take a look at get start page. Here is get start page. Get start page uses my little wrapper around JSoup, which I call JSouper just for fun. And this goes ahead and gets a page at this page URI, and it comes back as a document. So what that does in practice is it goes out and it snarfs down the contents, the HTML contents of that page, either from the website or the local file system. And notice we don't know or care at this level of programming. If you want to see how that works, take a look at the implementation of this getPage method, which is able to figure out whether something's local or remote and then do the right thing to download it. So once we've got that content, we then go ahead and turn it into a stream. So now we have a one-element stream containing the document or the page at the root URI. And now we're immediately going to go ahead and collect. Do not stop go, do not pass go, do not collect $200, and so on. And so what we're going to do is we're going to collect, but we're going to use the teeing collector. And at the high level, what the teeing collector is going to do is it's going to go ahead and have two mapping operations, one of which is going to count the number of images in the current page, and the other is going to crawl all the links in the current page. And then when those results come back, we're going to sum them up to be longs, and then we're going to have a merge function here that's passed as a method reference, which is the sum method on long, which will sum together the values of the number of images that were reachable from the page and the number of images on the page. And of course, this call here, we'll look at this get count of images in page in a second. It's very simple. But crawl links in page is a recursive call that will traverse through the links reachable from that particular page and then kind of do the whole thing recursively. But what's important to note here from a T collector point of view is the fact that we do this operation, and we then take the results and sum them. And if we had made this a parallel stream, which we did not, but if we had, which would have been absolutely trivial, simply by adding something like this, dot parallel. If you want to make a parallel stream, then those computations would run in parallel. Okay, so let's go take a look at get count of images in page. This is a very simple method. What it does is it uses the jsoup method select to go find all the img tags in the given page. So it comes back with the number. It comes back with a collection called elements that has those images. And then we just get the size of that. So that tells us the number of images that were in that particular page, which could be 0, by the way, but if there are images, it'll go ahead and count them. And then the second call here is crawl links in page. And crawl links in page is actually quite interesting what it does. It's a fun example of streams. It goes and it finds all the hrefs on this page. And it uses the select method in the jsoup library to find all the hrefs. You can see that comes back as a collection of so-called elements. And then it turns the elements collection into a stream. So we have a stream of elements. And then for each element, which is a hyperlink, we then recursively call count images. Count images was the entry point we looked at the beginning. And that's going to go ahead and pass in the hyperlink, which will either be from my local file system or from a website. And we increment the depth by 1. And what we get back from this, because we use map to long, is a stream of long primitives. And then we're going to go ahead and sum the results. So what comes back from that is a sum of the counts of all the images that are reachable from that particular page. And then you can see here, when we are all done and we have both those counts, the counts of the number of images on the page and the counts of the images reachable from the page, we're then going to go ahead and use the merge method to merge those results together to get a final count, which then comes back as the return value from this method. And that will, of course, come back up to where we called count images impl. So that's a quick walkthrough of this program. There's more to it we could talk about, but I want to keep it short for this morning. And if you want to see more about that, take a look. It's kind of a fun program, and it demonstrates several interesting things, not the least of which is the use of the teeing collector, as well as Java streams, sequential streams, as well also as this cool atomic check then act operation, put if absent, in order to be able to make those calls atomically. By the way, this is a bit overkill to use that put if absent here. And the reason for that is that this is not a parallel program. So this really becomes useful if we were running these calls concurrently, if I changed the stream to a parallel stream. But I just put it in there because it's a fun thing to understand.